Hi everyone, this is Dr. T. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Science. In the series of lectures of matrices and calculus, previous classes we discussed about Taylor series expansion of a function involving two independent variables x, y. Together with that, we studied about Euler's theorem for homogeneous function of degree n. Now, we will study about the concept of maxima and minima of a function involving two variables x and y. Now, we will see about the maxima and minima of a function involving two independent variables. Now see, what is maxima? In generally, whenever you are taking any function involving single variable f of x, there we will take y is equal to f of x. We will apply the derivative with respect to x, and we will equate that derivative expression to 0. We will get x values. We will call these x values as stationary points or are critical points. Again, we will calculate one more time derivative with respect to x. We will get f double dash of x. We will substitute in place of x with all these stationary points. If f double dash of x is greater than 0, we can say the function will have minimum value. If it is less than 0, we will have maximum value. If it is equal to 0, we can say it as further investigation is required, like a saddle point. Now, in the same way, a function involving two variables also, same procedure. Now we will see. Now, what is maxima? Maxima and minima are the highest and least values. The highest and least value. Highest value is called the maximum value. Sometimes we will call it as local minima, local maxima. So, the maxima and minima are the highest and least values, lowest values of the function can attain locally or globally. In a function of two variables, we will study the function having maxima or minima or neither maxima nor minima at critical points by using second order partial derivatives. It means take the given function f of x comma y. The partial derivative of f of x comma y with respect to x is denoted by fx. Partial derivative of f of x comma y with respect to y is denoted by fy. These two are called first order partial derivatives. Now here the process is, first we will calculate first order partial derivatives. We will equate these first order partial derivatives to 0. We will get two equations in two unknowns. The unknown variables are x comma y. By solving these two equations, you will get the set of all points denoted by x naught comma y naught. These points are called critical points. After finding these critical points, we will compute second order partial derivatives. By finding second order partial derivatives only, we can able to identify the nature of the function. Means either it will have maximum value or minimum value or neither maxima nor minima, based on these three second order partial derivatives. Now here we will calculate capital D is equal to fxx into fyy minus fxy whole square. Now we will substitute each and every point in this expression. We will get either this resultant value as equal to 0, greater than 0, less than 0. Now we will discuss about these cases. If its value means d value greater than 0 and fxx value is greater than 0 at a point x naught comma y naught, then we can say the function will have local minima. By substituting this point into the given function, you will get minimum value. So, what is the condition for getting minimum value of the given function? D value should be greater than 0 and fxx is greater than 0. Now, coming to second condition, if d is greater than 0 and fxx is less than 0, then we will have a maximum value at a point x0 comma y0. Now coming to third condition, if d value is less than 0 at a point x0 comma y0, then we can say the function will have neither maxima nor minima. Such type of points are called saddle points. Such type of points are called saddle points. For suppose if d is equal to 0, then we can say further investigation is required. Now we will see what is further investigation. So these are the conditions to decide whether the function will have maximum value at a given point, maximum value at the critical point, minimum value at the critical point, saddle point. Further investigation is required. Now we will see one example. Find the extreme value of f of x comma y is equal to x square y plus 4xy minus 2y square. First, after taking the given function, we will apply partial derivative to f with respect to x, partial derivative to f with respect to y. That is, fx is equal to dou f by dou x. Now, one thing you need to remember, if you are applying partial derivative with respect to x, treat remaining variable y as constant. So, the derivative of x square y with respect to x. Y is constant, derivative of x square is 2x. Next one, 4xy, partial derivative with respect to x. So, y is constant, 4 is constant. The partial derivative of x with respect to x is 1. So, 4y. Now, what is the derivative of minus 2y square with respect to x? Because y is constant, its derivative becomes 0. So, fx value is 2x plus 4, 2xy plus 4y. Similarly, calculate partial derivative to f with respect to y. That is, fy is equal to x square plus 4x minus 4y. Now, what is the second step? After finding first order partial derivatives, we will equate these first order partial derivatives to 0. Then what you will get? Fx is equal to 0 and fy is equal to 0. By equating these two equations is equal to 0, from first equation, we can find y is equal to 0 or x is equal to minus 2. Y is equal to 0 or x is equal to minus 2. Now we will substitute y is equal to 0 into this equation. We will get the corresponding values of x. In the same way, substitute x is equal to minus 2 into the same equation, that is this equation, we will get the corresponding values of y. It means corresponding y value, you will have x values from this equation. Same way, corresponding to x is equal to minus 2, you will get y values from same equation. So, let us take y is equal to 0 into second equation. You will have x is equal to 0 and x is equal to minus 4. So, corresponding to y, you will have x two different values. So, what are the critical points? The critical points are 0, 0, minus 4, 0. This is corresponding to y is equal to 0. Now, coming to corresponding to x is equal to minus 2, corresponding to x is equal to minus 2, you will have y is equal to minus 1 by substituting x is equal to minus 2 into second equation. Then what is the stationary point? Minus 2, minus 1. So, these three are said to be critical points. After finding critical points, as per procedure, we are going to calculate second order partial derivatives to decide the extreme values of the given function. So, the second order partial derivatives are fxx is equal to 2y, fyy is equal to minus 4, fxy is equal to 2x plus 4. Next, calculate fxx into fyy minus fxy whole square. Now our aim is to find the value of capital D corresponding to these three critical points. Now, anyway, we have 3 points. At 0, 0, based on the second order partial derivatives, the value of fxx is 0, the value of fyy is minus 4, the value of fxy is 4. Just by substituting in place of x with 0, y with 0 in all second order partial derivatives. Then what is the value of d? D value is equal to minus 16. Clearly, d is less than 16. So based on our procedure, if d is less than 0, we can say the function will have neither maxima nor minima. So such type of critical points are said to be saddle point. Coming to second point, minus 4, 0. Substitute x with minus 4, y with 0 in all second order partial derivatives like fxx, fxy, fyy. So, after substituting these points into second order partial derivatives, you will have these numerical values associated with the second order partial derivatives. Next, immediately calculate d value. Again, we are getting answer as minus 16. So, d is less than 0. Hence, the function will have neither maxima nor minima. Hence, the critical point is said to be saddle point. Now, coming to third point, minus 2, minus 1. Again, substitute in place of x with minus 2, y with minus 1 in all second order partial derivatives. Calculate d value. After substituting all partial derivatives, the d value becomes 8. Clearly, it is greater than 0. And d is greater than 0. Again, we need to check one more condition. fxx is less than 0. Hence, the function will have maximum value. The function will have maximum value. It means what? At a point minus 2, minus 1, we decided the function will have maximum value. If you want to find maximum value, just substitute the point with minus 2, minus 1 in place of x with minus 2, in place of y with minus 1 into the given function. After substituting this point, you will get the maximum value as minus 2. So this is how we can able to identify really whether the function will have maximum value or minimum value, neither maxima nor minima. So what is the conclusion? Out of 3 points, the points 0, 0 and minus 4, 0, at 0, 0 and minus 4, 0, the function will have neither maxima nor minima. So we will call these points as saddle points. Means at saddle points, neither maxima nor minima. Now coming to the point minus 2, minus 1, we obtained the function will have maximum value. Now, what is maximum value? Is 2. Now, we'll see one more example. Find the extreme values of f of x, y is equal to x cube plus y cube minus 3x minus 12y plus 20. Similarly, here we will calculate first order partial derivatives. Fx is equal to 3x square minus 3. Fy is equal to 3y square minus 12. Now, we will equate these two equations to 0. Then we will get fx is equal to 0 and fy is equal to 0. Now, our aim is to solve these two equations. If you are equating fx is equal to 0, you will have 3x square minus 3 is equal to 0. Hence, x value becomes plus or minus 1. In the same way, from second equation, we will have 3y square minus 12 is equal to 0. Then y value becomes plus or minus 2. Now, how to find the critical points? We will take all possible combinations. Fix x is equal to 1. Take y possible values. So, 1, 2. Next point is 1, minus 2. Similarly, fix x is equal to minus 1 and means pair with y. Then what you will get? Minus 1, 2 and minus 1 comma minus 2. So here we will have 4 different critical points. Now our aim is to decide at these 4 critical points whether the function will have maxima or minima or neither maxima nor minima. If you want to decide it, first of all you need to identify second order partial derivatives. What are the second order partial derivatives? fxx, fyy, fxy. So these are the second order partial derivatives. Immediately calculate d value. What is d value? fxx multiplied by fyy minus fxy whole square is equal to 36xy. Now at each and every point we will see what will happen. At 1 comma 2 the value of fxx is 6, fyy is 12, d value is 72. Clearly it is greater than 0. And what is fxx? 6. Clearly it is also greater than 0. Hence what is the conclusion based on our procedure? The function will have a local minima at a point 1 comma 2. Now coming to second point, minus 1 comma minus 2, the value of fxx is minus 6, fyy is 12 and d value is 72. Clearly it is greater than 0. Now what is fxx here? fxx is minus 6. Clearly it is less than 0. Hence the function will have maximum value at a point minus 1 comma minus 2. Now coming to remaining point, at 1 comma minus 2, clearly the value of capital D is minus 72. It is less than 0. Hence we can say the function will have neither maxima nor minima. So the point 1 comma minus 2 is called saddle point. Similarly for the point minus 1 comma 2 also. Substitute in place of x with minus 1, in place of y with 2 in second order partial derivatives. Find out the value of capital D. D value is minus 72. Clearly it is less than 0. Hence the function will have neither maxima nor minima. So the point is called saddle point. So out of 4 points, 2 points, at 2 points the function will have minimum value and maximum value. At remaining 2 points the function will have neither maxima nor minima. Once if you decided the function will have at maximum value at one point, minimum value at other point, immediately substitute these 2 points into the given function, then we can find what is minimum value of the given function, maximum value of the given function. So at a point 1 comma 2, already we found the function will have minimum value. So substitute this point into the given function, you will get answer as 2. So 2 is the minimum value. Similarly, at another point minus 1 comma minus 2 we will have maximum value. So substitute this point into the given function, in place of x with minus 1, y with minus 2, you will have the function will get 38 is the value which is a maximum. So this is the procedure how to find maximum value or minimum value or neither maxima nor minima from the given function. Again I am repeating the procedure. Take the given function, find first order partial derivatives. One is with respect to x and other one is with respect to y. Equate these two partial derivatives to 0. By solving these two equations, you will get stationary points. We will also call it as critical points. Next, immediately find out second order partial derivatives, that is fxx, fxy, fyy. Later, find out d value. Next one, substitute critical points one by one into capital D as well as into second order partial derivatives. So based on the conditions, we will decide whether the function will have maximum value or minimum value or neither maxima nor minima. I already told, if d is less than 0, the function will have neither maxima nor minima. So the point, critical point, is said to be saddle point. Once if you decided the function will have minimum value or maximum value, substitute these points into the given function, you will get the minimum value of the given function at a critical point. Similarly, the maximum value of the given function at a critical point. Now, I provided worksheet problems. Please practice all these problems. Answers also provided. See, at the time of solving problems related to maxima, minima, please focus mainly on partial derivatives. And one more thing, solving two equations for critical points is very, very crucial. After finding critical points, the procedure is very simple. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.